In this question we have a cylindrical silo, but there's a hemisphere on top, like you may have seen on farms sometimes. And what we're looking for is the minimum cost under the conditions given. Well, it's kind of a lengthy answer, so I'll give you a screenshot of the complete answer before going into it in detail. Okay. Now, looking at it in detail, we know that the entire volume is 500. Well, the volume of a sphere is 4/3 pi r cubed, and that means that the volume of the silo is the volume of a cylinder plus 2/3 the volume of a sphere, since it's only half of a sphere on top. So 500 equals pi r squared h plus 2/3 pi r cubed. What we want to do here is isolate the h, so that by doing that we only have one variable in our surface area formula, because remember, what we're trying to do is minimize the cost. Now, we know that the surface area of a sphere is 4 pi r squared, and we know that the cost is going to be $40 times the area of the walls plus $100 times the area of the sphere. Plugging in an h of 500 over pi r to the negative 2 minus 2/3 r, we get a cost formula in terms of only the radius as given here. And collecting up our like terms, we get a slightly simpler version of that right here. Now, we know that the radius has to be greater than or equal to 0 greater than 0 in order to accommodate 500 meters cubed of corn. The smallest possible height would occur if all the volume was in the hemisphere, and if all the volume was in the hemisphere, then r would be 6.2. So we know that 0 has to be less than the radius, and the radius has to be less than or equal to 6.2. These are the end values of our domain in this question. And what we're going to do next is take the derivative of the cost function with respect to r and set it equal to 0. And in doing that, we get r equaling approximately 3.5. Now, we take the limit as r goes to 0 of the original expression. Well, this term becomes 0, but this term grows without bounds, so that would be infinity. If we let r be 3.5, we would get a cost for the silo of $17,000 and change. If we let r be 6.2, we'd get a cost for the silo of $24,000 and change. So we see that the minimum cost is approximately $17,072.96.